Alright, welcome back to day 34 of LeetCode grind solve or go home. 30-minute solve or go home. Okay, let's see. Convert a sorted list into a binary search tree. Oh, great, okay. Given the head of a singly linked list where elements are sorted in ascending order, convert it into a height balanced BST. First problem, a height balanced BST is defined as a binary tree in which the depth of the two subtrees in every node never differ by more than one. Okay, that's fine. Can I just run through the linked list, build an array, and then use the array to build the tree?
Yep, that's an excellent strategy.
Okay.
It's the most straightforward.
Alright, sure. So I'm gonna do that first. Okay, so linked list nodes equals empty array while head nodes dot append head dot val head equals head dot next. That should get me all of it. Let's see if nodes are good. Okay, I have the array now. Okay, to build a binary search tree, you need to make sure the elements are in the proper order. So if you start as -10 as the head, then you're basically screwed, because then you're going to be setting everything to the left, well, no, to the right, and that's not balanced. So I think this optimal strat typically is to use the middle node as the head, because it's sorted already. So you want to use that. So you pop that out, use that as the head, and then everything to the right and everything to the left should be the left tree and the right tree. That sounds good. Okay, so I'm gonna do mid equals len nodes divided by 2, and then I'm gonna put that as the head. So head tree equals tree node of nodes mid. Okay, and then now we have indexes of the left. Okay, so I guess I'll just separate the nodes into a left array and a right array. So left nodes equals nodes from 0 to mid. Right nodes equals nodes of mid on. Wait, does that work? I'm going to print to make sure those are the proper indexing. Yes, I did. Peoples are having a great time outside. Okay, so 10, 3, 0, 5, 9. So that's wrong. So it should be mid plus 1. That should get me the right arrays. Okay, yeah, that's good. Okay, so now I loop through these, right? And then, okay, so it's already sorted. Okay, I think, yeah, so it's kind of recursion based. You probably want to get the middle each time, and that's your next child. And then the left and right is separated again. And then those are, but it's slightly confusing on how to handle that. Okay, so.
Well, if you don't want to do recursion in your main function, what can you do?
You can do a stacky.
No, I mean, you could do a stack. In which case, yeah, I guess that's possible. If you have the correct pointers to each thing, then you can do like bit or something, right?
Yeah.
Otherwise, you can do recursion in a helper, right?
Yeah, you can do it in a helper. Yeah. Yes, for sure. Probably you want a helper. Okay, so I think this helper you'll probably pass in the array, and then that array will handle getting the mid, and then separating the left and right, and then it'll pass in the left and right again until it's done. Oh, you probably also want to pass in the tree as well. Tree, and then this. Wait, is it? Do you want both of these? Yeah, you do. Okay. So yeah, it would be, you would get the mid. The mid of left. Mid left.
I see. I believe you are making it more complicated than you need.
Oh, really?
If you want, the helper should really just take the array and then return a tree. Right?
Yeah, but then, so how when you separate the tree into the left side and the right side, how does it know? Because in like each iteration of the array, you need each iteration of the array you want the mid.
You assign the return values left to be recursively calling the left nodes as the array.
Yeah, okay, yeah, I see what you mean. Okay. Yeah, so basically you're only passing in one array.
Right, right. Because if you
okay.
zoom in, then it becomes more complicated to handle each case.
Okay, yeah, I think I know what you're saying. So mid would equal len.
You don't even need tree. Tree is what you return.
Sure. Okay. Sure. Oh no. If you don't pass in tree, how do you have access to it?
You make the tree to return it.
Yeah, I understand that, but then if you're recursively calling it, the tree resets, right? You need a tree?
Yeah. But you return at the end.
Okay. No. Okay. Wait. So if I do like, let's say right here, tree equals like none, and then I set it up, and then I return tree here, right? Doesn't, and then you're not returning tree, you're returning the helper, right? The helper, you need to keep calling the helper multiple times, right?
Well, okay, well, kind of, but wait, pick something to return, and then that will be what you return.
So I want to return the tree, but the problem is.
And return tree. That's fine.
The problem is if you're calling this recursively, does it even have the pointer to the correct thing anymore?
No. Well, tree is first defined in 17, and then you do stuff.
Yeah, but when I'm doing stuff, I'm calling like helper. I'm calling helper like multiple times, right?
Yeah, that's fine.
But every time you call helper, the tree is reset to none, isn't it?
No, because that's okay. First of all, let's clean this up first. You need a proper definition in line 15. You need to check if nodes is null, etc. Right? Like, yeah. Do all that first, and then it will make sense. So then you should be returning node, not tree. I don't know where tree's going from.
No, this is the.
No, well, you're creating the root of the tree.
Yeah, no, but that's, you create the root of the tree on the first go around, but then afterwards you want.
Well, then you return node.
Do you?
Okay, okay. Let's take one step back. What happens if nodes is null? What should you return?
If nodes is null, you return none, which the tree is none.
Right. Okay. So can we set ret equals or node or tree or whatever you want to return
Yeah,
equals?
tree equals none, sure.
Well, that's important in the helper because when you call it on the left side that doesn't exist, right? Then you can return nothing.
Mm-hmm. But then, okay, wait. But this tree is the entire tree. It's starting from the head, right? If you,
That's fine.
yeah,
That's
okay.
fine.
But then every time you call helper, doesn't it reset tree to
Oh,
none?
no. But you're calling helper to fix to it. What are you calling helper on first of all? And you should in line 22 you should set instead of node use tree. You're making tree everywhere.
Gee, okay, wait, no. So my thought process is the tree. You do a tree dot left and a tree dot right, but it looks like you're
Yes.
just setting
No,
the tree.
that's correct. That's correct. You're absolutely correct.
But then if you just do tree equals, doesn't that just reset the tree each time? That doesn't seem correct. I don't know. I'm slightly confused here.
Okay. Then what should happen is if not nodes, return null or return none. Right?
If not nodes, yeah, you return none. No.
Okay.
Wait, if not nodes, yeah, so that means there's no nodes, then you're returning none, yeah.
Right.
Else, you run the algorithm.
Correct.
Okay. So,
This helper thing, what are you assigning it to?
what do you mean? What do you mean by what am I assigning it to?
Why do you, when you calculate helper of nodes 0 to mid, what does that do?
Oh, that gets me the left side of the tree.
Okay. And where do you assign it to the left side of the tree?
Where do I assign it?
At what point do you say left side of tree is equal to
Oh, you mean tree dot left equals that. Oh, I see why this works now. It's because you assign
return tree should be inside the else.
Mm-hmm. So because you're assigning the left to the helper, and each helper returns a node, then that works.
Your definition in 15 is also wrong.
What do you mean? That's not a definition.
Yeah,
Oh.
what the hell is 915?
Oh, whoops. Yeah. Wait, does this work? Okay, so if I pass in 0, okay, let's get rid of this shit first. If I do this, it goes 0 first, grabs the mid. Tree is now 0 to start. Then I set tree dot left to the helper of the middle of 10 and 3. Negative 10, negative 3. The middle of 10 and negative 3 is, I believe that's, well, it's going to be divided by 2. 2 divided by 2, which is 1. So it's going to put negative 3 as the left. And then this one would be the right of the tree is, it would be this 2 divided by 2, which is also 1. Just put it 9. So it's going to be 0, negative 3, and 9. and then it's gonna send the array back in. Wait, no. Okay, wait. So it's gonna, okay, so tree.left will set this, and then when and then it comes back in here, it's gonna call the mid again of nodes. Wait, hold up. Yeah, when I pass this in, and I set the tree to the mid, okay, and then tree.left of that left, it's gonna call 0 to mid. So I guess in this case, mid nodes will only have, wait, nodes have 2 elements here. 2 elements. So 0 to 2. 0 to 2, and then this is, okay, yeah, so right won't have anything because it's going to be empty. But left, 0 to 2 is still -10, -3? Wait, no, mid's 1, my bad. Okay, yeah, so it's going to only send in -10. So tree.left of -3 is -10. This one is, okay, that looks like it does work for this scenario. But then if it has more stuff, does it still work?
Why are you so skeptical, dude?
I don't know. It's just,
do you not trust recursion?
Recursion sometimes it's like a magic box. Sometimes it doesn't. You don't know if it works properly or not.
I mean, it's the same problem that you do in the one below it, right?
Oh, what's the one below it?
At each level, you're setting the left side to process the left array, the right side to process the right array.
Yes. It's just okay. I mean, this looks like it seems like it works. It's just I don't know if it handles every edge case, but I don't know.
Alright, what happens if there's one element in nodes?
If there's one element, so if there's one element, nodes will have one element. It's gonna come in here. It's gonna say, oh, there is nodes, so you do else. Mid would be the length of that divided by 2, which is 1. So tree is gonna be that, and then tree of left and right is gonna pass in empty arrays. And it's gonna come in and say nodes is none, so return none for both of those.
Right, that's fine. Okay, what if nodes is empty?
If nodes is empty, okay, so nodes, this one is empty array, does this, empty. So if not nodes, just gonna return none. So the tree is just gonna be none.
Okay, doesn't that cover all your cases?
I mean, those are, no, I wasn't thinking of those edge cases. Those are fine. I'm just like saying, like, what if the tree is like weird? Does it do all?
Okay, make a weird tree. Let's see what happens.
I have no idea how a weird tree looks like. Hold up. Oh yeah, it has to be sorted. Yeah, I forgot. Okay, so if I do like 12, 15, -8, -7. Does that work? It does work. Okay, I mean, I don't know why I'm so skeptical, but I guess it works.
Okay. At every point, you're picking the middle guy.
Yeah.
Okay. And then you're choosing to say that's the center of the next level, right?
Yeah.
And then, so the left of the next level, the tree on left of the next level, you just run the same process on the left half, right? So at any point, you're pretty much kind of reducing your search space by a factor of 2.
Yeah, for sure.
And then at some point, when you see that you have nothing to go anymore,
then you return none.
But
then when you say return none, that basically means the tree of what, like, you passed in. It's just, if you return none, it's just not doing anything, right? It just means.
Well.
Oh wait, no. It says tree dot left. You call the helper, so if it returns none, that means tree dot left is none.
No. So why is this still balanced?
Yeah.
What is the maximum difference between the left and right in this case? If you always choose the middle.
It's always gonna be 1 because the middle.
Well, be 0.
Or it could be okay. Always less than 1. Sorry.
Right, because some of them is going to be none, and the only time it's none is when that part of the array is empty.
Yeah.
Right?
It's because you're always doing middle. You're always gonna be balanced.
Well, you're always going to be as balanced as possible.
Yeah.
Which means that you can have
Well, yeah, you can have one off,
one
but
side having stuff, the other side not having stuff. But for that to happen, you must have an array of like size 2 or something, right?
yeah. Mm-hmm.
So if you have any array that's larger than that, you can always place it. And if you have any array that's smaller than size 2, as in size 1, then it's balanced because both sides are 0 or null. None.
I see. Okay.
So like pretty much you whittle down the array over time, and then
Mm-hmm.
one side is going to have at most one. So it's either going to be 0 0, 1 0, or something, right?
Yeah.
And that's why if it's something, you can always run further.
Mm-hmm. Okay. Wait, so I think I see what you were saying before. You technically don't need to do it like this, right? You can just do.
No, you could switch the conditions and it's the same as long as you return tree inside the part where you define the tree at the end. That's fine.
Yeah, if I just did it back like this,
Yeah.
tree equals none, and then return tree outside. That should still work, right?
Yes, maybe.
I think so. Let's try empty then. Yeah, it still works. Okay, yeah, that's fine. Trees none, return tree at every helper. Yeah. So basically, if it gets reset to none, that's fine. But then if there's nodes, it actually sets it, and then that's fine. Okay, so technically this isn't tree. This is just node. It's because then you're making a new node each time. You're not making a new tree each time. But that's fine.
Right.
Yeah, better wording would be node, I think.
Well, technically, you're making it. I mean, a tree is a node. It's a tree node.
Well, sure, okay. But I was thinking more of the tree as like the overarching tree that you're returning at the end of the.
No. That's typically not how the recursion would work. If you want to do something like that, you would use like this. Then you would return the, you know, the furthest out with the root.
Mm-hmm. Okay. This is fine then. All right. Cool. Thanks.
Yeah. Okay.
All right. Later.
Yeah.